In this chapter, we will be continuing your study of trigonometry. In this lesson, we will study oblique triangles using the cosine law.
All right, hi everybody. In the last lesson we looked at something called the sine law. And we used that to work with triangles that were oblique, that were right angle triangles. Okay, and we saw that was a great little law. It was the side of a triangle divided by the sine of the angle opposite it, and that's going to be equal for every pair of side and angle that you get there. Now, that works if you've got an angle and the side opposite it. Now, there is another law here called the cosine law, and it deals with a slightly different situation. If you know, for example, an angle and the two sides next to it, okay? So you've got this side, you know the angle, and then you know the side here. You can use that information to find the side opposite that angle, and you use the law that looks like this, okay? Where a squared, okay, is going to equal b squared plus c squared minus 2bc multiplied by the cosine of the angle in between those two sides there. Now, this looks fairly complicated, but actually you should recognize, okay, you should recognize the Pythagorean theorem in there. A squared is equal to b squared plus c squared. Now, the law of cosines is actually just an adjustment to the Pythagorean theorem to work for triangles that aren't right angle triangles. Okay, and you get this right here. This is just this little multiplication, sorry, not the multiplication factor, but it's this little additional term in the Pythagorean theorem that allows us to work for oblique triangles. Now, the other situation where you might use the cosine law is when you're looking for an angle. So just like with the sine law, we used it to find sides and angles. You can use that to find, you can use the cosine law to find sides and angles as well. In this case, though, what we're going to do is we're just going to simply rework this equation. We're going to use it to solve for the cosine of A. So we bring over all these terms, we divide by this negative 2bc, and you get this expression right here. And so all you would have to do here at the end is you would get that A is going to equal the inverse cosine of this expression here. Okay? Now, it's important to notice that the angle that you're looking for, if you're looking for angle A, then you're going to subtract, up in the numerator, you're going to subtract little a squared. Okay? If you're looking for side A, then you've got to use the cosine of A, the angle opposite it, up here in this law of cosines. With this particular law, everybody, I'm not going to show you where it comes from, and the reason for that is because it requires an idea, a concept that at this level you just have to accept on faith that what I was telling you was true. Okay, so instead of working this all through to a point where I'd have to look at you and say, okay, well, believe me that this next statement is true. Believe me that the law of cosines works, and then we're going to just go through a bunch of questions and apply it. Beautiful thing about the law of cosines is you don't have the ambiguous case like you do with the sine law. The cosine law really just works super well. Okay, and don't worry about it. There's no such thing as the tangent law, at least. Okay, we're not going to look at anything like that. It's just the sine law and the cosine law. That's it. And yeah, so here we go. Away we go. Let's take a look at some examples so you can see how it works. All right, so in this first question here, I've got side 15, side 12 here, and this 32 degrees in between, and I'm looking for the angle, the side opposite that angle. Now, I know this isn't a sine law problem, okay, because I do not have an angle side pair. Okay, and then in fact, there's no way for me to kind of get that information out of this. So this is definitely a cosine law problem. So x squared, okay, the square of the side opposite is going to equal these two sides squared. Now, it doesn't really matter what order I put those in. I'm just going to take the two sides squared and add them together as if it's the Pythagorean theorem. Remember, that's how that works. Now I'm going to subtract 2 times 15 times 12 times the cosine of that angle in between. Now, I want to make sure that we're really clear on this. I've watched so many people mess this up when they go to their calculator to enter this in. Okay? And even after I've warned people about the mistake that they could make here, they still make it. This cosine of 32 is being multiplied by this 2 times 15 times 12. what I see people do all the time is they'll go on their calculator, they'll go 15 squared plus 12 squared, and then they'll go minus 2 times 15 times 12, enter, and then they'll multiply by the cosine of 32. If you do that, what you end up doing is multiplying cosine of 32 by this whole expression here, by these two terms as well. Please don't do that. This is all one term. Don't multiply by the cosine of 32 after evaluating what that is. Okay, that's incorrect. The best way that you can do this, okay, and I mean this sincerely, your calculators, in fact, all your calculators here can handle this. 15 squared plus 12 squared minus 2 times 15 times 12 times the cosine of 32, and close the brackets. Just do it all in one step. Don't split it up into different pieces here. If you do that, you're very likely going to do that wrong. Press enter. And we get here that x squared, bear in mind it's still x squared, is equal to 63.7, and it goes on and on. To get x, what I need to do is take the square root of that answer, and I get to the nearest, well, to the nearest tenth. I'd have to round that up here. What did it say here? Yeah, I didn't say. So to get to the nearest tenth, I'd have to round that. So x would equal approximately 8.0. We usually round sides to the nearest tenth. Okay, and so there you go. That's the side of x. Right. In this question, we're going to use the cosine law to do the exact opposite. We're going to find an angle here. Now, which angle? Let's just label the sides here, the corners here real quick. ABC. Which of these is going to be the smallest? Now, you can't trust the diagram because math teachers were notoriously bad at drawing. So you gotta trust the labeling. So the smallest angle is going to be opposite the smallest side. And the smallest side here is this one. So we're looking for angle C. Now, angle C is going to be the inverse cosine of. All right, now, bear in mind what I told you before. If you're looking for angle C, then up here in the numerator, I'm going to subtract little c squared, side c squared. So it's going to be minus 5 squared. So I know that that's what it's going to look like. The other two sides, it really doesn't matter what order you put them in. They're going to be squared and added up on the top, and in the denominator I'm going to multiply them by 2. Okay? So that's what that has to look like. Now the real issue comes with putting it in the calculator. Now, I'll see people screw this up all the time, and let me just walk you through a very common mistake here. Now what I'm about to do here is incorrect. Okay, I want you to see what's going on and understand why. So x squared plus 11 squared minus 5 squared divided by 2 times 8 times 11. People are going to close the brackets, press enter, and go, why? Why? I did exactly what you said. No, you didn't. No, you didn't. What you entered in here was 8 squared plus 11 squared minus 5 squared, but only the 5 squared is divided by 2, and then just that result is multiplied by 8 times 11. Okay, so essentially, that's what you did. And then you subtracted that from 8 squared plus 11 squared. That's not at all what I wanted you to do here. This whole thing needs to be in parentheses. So I'm going to press second enter. Well, actually, I didn't need to because I just came back to that. What I need to do here is I need to insert, and I do that by pressing second and then delete. The above the delete is the insert. And I'm going to put a set of parentheses in front of the 8 squared. And I'm going to put a set of parentheses behind the 5 squared so that the numerator is in brackets. Now, bear in mind, I still need this other set of brackets here for the inverse cosine. I just need to put the numerator in brackets. Then I need to put the denominator in brackets. And then I got to close out that other set of brackets for the inverse cosine. Okay, so you got to be generous here. Brackets around the numerator, brackets around the denominator, brackets around the whole thing. Press enter. And to the nearest angle, to the nearest degree, 25 degrees. Okay, so please watch out for that. Like I said, even when I tell people the correct way to do these things, oftentimes they're getting it wrong, or they'll look at it and say, why is the calculator giving me this bizarre answer or this error here? And in a lot of cases, it's because of the brackets. We're just doing the brackets wrong. Right, so this next question here, if you look at it, it's going to look really similar to the questions we did with the sine law. Triangle MPN, okay, let's draw that out. MPN. P is 48 degrees. Okie dokie. Little m is 7. Little n is 8. And we want to find angle M. Okay, well, there are a couple of ways that we could really walk through this, but for right now, the first thing, I'm going to have to find little p. Based on the information I've got, I can't use the sine law because I don't have an angle side pair. The only thing I can do is the cosine law, and the only thing I can solve for is the side opposite that angle. So let's do that. So p squared is going to equal 8 squared plus 7 squared minus 2 times 8 times 7 multiplied by the cosine of 48 degrees. And I am a big proponent of just plugging that into the calculator. So 8 squared plus 7 squared minus 2 times 8 times 7 multiplied by the cosine of 48 degrees, the angle in between them. And I get 38 point blah, blah, blah. Okay, so p squared is going to equal 38.057 dot, dot, dot. P is going to be the square root of that. So second square root of that answer. Okay, and I get 6.2. Now I'm going to leave this number in my calculator right now, but 6.2. Okay, so now I know the side opposite here. Now, I could do this one of two ways. Okay? I could use the sine law to figure out what that angle is. Now, I shouldn't actually end up with a problem here, okay, because normally you'd think about the sine law giving you the ambiguous case, but I already know all three sides, so I already know more information about this triangle than I did with those previous questions. Or I could use the cosine law to find angle M. Now, to start off with, I am going to use the cosine law. Okay, so angle M is going to be the inverse cosine of, and that is going to be, now bear in mind, I'm going to subtract the 7 squared up there. That's the link. Okay, I'm looking for angle M. I'm going to subtract little m squared. So this is going to be 8 squared plus, now I'm just going to say p squared. And this will be over 2 times 8 times p. Now when I go to my calculator, instead of the p, I'm going to use answer because I already figured out what little p is here. So this is going to be the inverse cosine of, brackets for the numerator, 8 squared plus p, which is going to be second answer squared, minus 7 squared. Now close the brackets for the numerator, divided by open brackets for the denominator. 2 times 8 times, and again, that p is the answer above there, and close brackets for the whole thing. When I press enter, I'm going to get, to the nearest degree, 57 degrees. Okay, 57 degrees. Good. Now, I could do it that way, or I could use, the sine law. Because now what I've got here is I've got little p over the sine of 48 degrees is going to equal 7 over the sine of m. And I'm going to walk this thing through so you can see this. Okay. I'm going to cross multiply. P times the sine of m is going to equal 7 times the sine of 48 degrees. So the sine of m is going to equal 7 sine of 48 degrees over p. Now to figure out what m is, okay, bear in mind I'm going to take the inverse sine of that. Now the first thing I got to do is I got to go back and got to grab p again. So there was p, right? Okay, so I'm going to just drop that down right there, press enter. So that's the last answer. There's my p again. Now, second sine, okay, 7 times the sine of 48 divided by p, second answer. When I do that, I'm going to get, there it is, my 57.48. Okay, my 57.48. So 57 degrees. Now, because of the sine law here, this could have been or it could have been 180 minus that. Or it could have been 123 degrees. I've got two possibilities here. So this is the issue with the sine law. So let's go back though. We were looking for angle M. This could have been 57 or 123. Now here's the thing. 57 Okay, 123. Now we already know that this side right here was 6.2. That means this is the smallest angle. Okay, M's got to be the in-between one. But if M is 123 degrees, that makes it by far, it has to be the largest angle here. But I know that it can't be because N has to be the largest angle because it's opposite the largest side. So just by looking at the sides that I'm given, I can deduce that that can't be 123 degrees. It would have to have been 57. So the cosine law here, maybe a little bit more work to work with in terms of entering it in and being careful with the brackets and whatnot. Sine law maybe is a little bit easier to get your head wrapped around, but you've got to just take a look at that answer and do a little bit of an evaluation there and just figure out which one makes the most sense. Okay? All right. So this question here is asking us to solve the triangle PQR. Okie dokie. PQR. We know that little p is 3, little q is 5, and little r is 5.2. Okay, so we've done this before. In this particular case, though, I'm looking for the angles. Now, I would kind of advise you to let's look for the largest angle first. Okay, and I'll explain why in just a couple seconds here. Let's look for the largest angle first. So r is going to equal the inverse cosine of, now up here, remember I'm going to put minus 5.2 squared. And then with the other sides, it doesn't really matter what order we put those in. That's okay. So, whoops, sorry, this just becomes a little bit of calculator work. Inverse cosine of, now remember, I got to put a second set of brackets for the numerator. So 3 squared plus 5 squared minus 5.2 squared, close brackets, divided by, open brackets, 2 times 3 times 5, close brackets for the numerator, close brackets for the cosine. And to the nearest degree, okay, we get 77 degrees. So r is going to be 77 degrees. Now I'm going to keep that angle in there for right now. Now, I'm going to use the sine law, because the sine law is a little bit easier to use here. And it's just that this is what most people are going to do. I could very easily, by the way, just repeatedly use the cosine law. I could use the cosine law again to find another one of the angles. That's okay. But I want to show you what I see a lot of people do, and that's use the sine law, because now we know r, 5.2, over the sine of 77 degrees, and that's going to equal, I tell you what, let's find the smallest angle now. Okay, let's find p. So 3 over the sine of p. So we're going to cross multiply 5.2 times the sine of p, whoops, p. Well, I don't know why I wanted to write a different letter there. P is going to equal 3 times the sine of 77 degrees. So the sine of P is going to equal 3 sine of 77 degrees over 5.2. Oh, sorry, you can't see that. It's gone off to the side there. Now, P is going to be the inverse sine of that. So second sine, and what did I get here? I got 3 times the sine. Now, I'm going to use this right here, second answer, close brackets, divided by, and I believe it was 5.2 there. Yeah, 5.2. And I'm going to get 34. To the nearest degree, 34 degrees. Or 180 minus that answer, because it could be first or second quadrant. That's the thing about the sine law. In which case, it could also have been 146 degrees. Okay, but now here's the thing. I just went through and used the cosine law to find the largest angle in the triangle. I know this is the largest angle because it's opposite the largest side. So P is supposed to be the smallest angle. It can't possibly be 146. It's got to be 34. Okay? So I know that angle R is 77. I know that angle P has got to be 34. And to find angle Q, I'm just going to subtract those two from 180. Okay, so 180 minus 77 minus 34. I know that angle Q has got to be 69 degrees. Okay, again, I could have used the cosine law just a couple of times and then subtracted the angles from 180 to get Q. But again, I wanted you to see this and have an idea of how to approach it and how to interpret the results when you start using the sine law. Okay, in this case here, when we take a look at this application here, it's actually pretty straightforward. We can see the following measurements made by a surveyor. He's looking at the side here. He's already measured this out to be 220. He's measured this out to be 150. He can measure this angle here. Maybe he's looking at trees here. He's got a tree here at the side of this lake, and then he's standing at this tree right here. He's measured those distances. He knows this is 120 degrees. We want to find the width of the pond. Okay, well, that's just the side opposite that angle. So we know that W squared is going to equal 220 squared plus 158 squared minus 2 times 220 times 158 times the cosine of the angle in between them, 120 degrees. And again, I'm running off the screen there. Now that looks intimidating, but I'm going to use the calculator to do that anyway. So 220 squared plus 158 squared minus 2 times 220 times 158, times 158 multiplied by the cosine of 120. Okay, and I get this 108,124. Yikes, that's a big answer. But bear in mind, I got to square root that to get W. I got to go one step further, and I get 328.8 meters. W is equal to 328.8 meters. So just remember to take the square root at the end. All right, everybody, one last application question here. It says from the top of a tree, okay, the distances to the two peaks of mountains are 64 kilometers and 97 kilometers. And let's say we know the distance between those two peaks is 127 kilometers. What's the angle between the two surveying lines? So we want to get angle theta there. Now remember, this is going to be, because I know all three sides, this is going to be an inverse cosine question, cosine law. I'm going to have this set of this fraction inside here. I am going to always subtract the side opposite the angle squared. So I know it's going to be minus 127 squared up in the numerator. Then it doesn't really matter what order I put the other ones in. So 2 times 64 times 97. It doesn't matter. As long as whatever angle I'm looking for, I'm subtracting that side opposite it squared right there. And now again, this just becomes calculator work. So second cosine, again, brackets for the numerator. And that was 64 squared plus 97 squared minus 127 squared. Whoops, sorry, you can't see that. Sorry, I keep looking back at the notes there. Divided by, I got to close the brackets for the numerator, divided by 2 times 64 times 97. Close brackets for the denominator. And the answer is 102 degrees. That's the number we're looking for.